గట్టిగా
ఏమో పాప ఫస్ట్ టైం కదా, మళ్ళా సెకండ్ టైం కూడా పోతే నేనేమైనా పట్టించుకోవట్లేదు అనుకుంటున్నారు. నేను పోయినట్టు నాకేం తెలియదేమో, నేనేం పట్టించుకోవట్లేదేమో అనుకుంటున్నారు. ఫస్ట్ లోనే ఎందుకని కామ్ అయిపోయినా, మళ్ళా అదే రిపీట్ చేస్తే కోపం రాదా? నేను అదే చెప్పేది, తెచ్చుకున్నాను అంటే ఏదో అవసరం ఉందనే కదా తెచ్చుకున్నాను, ఊరికే తెచ్చుకోను కదా. తమాషా పడుతున్నాడు, కనుక్కోవట్లేదులే చూడట్లేదులే అని అనుకొని తీస్తున్నాడు బాగా. ఇదే తల్లి
ఇచ్చేసారు. అవి మ్యూట్ చేసుకోవాలి, పెట్టాను. శైలు చూసుకోవే. వాళ్ళిద్దరు నిజంగానే వెళ్ళలేదే, ఇద్దరిద్దరు ఫోన్ తీసుకుంటున్నారు. మళ్ళీ ప్రోగ్రామ్ హెడ్ లో ఆపారా? ఆపారు. లేదు, అది ఆటోమేటిక్. అదే అదే మీరు చూడి ఇప్పుడు ఎలా కాబట్టి పండుగ పెట్టుకో, పండుగ ఎక్కడ పెట్టాలి అందుకని ఇప్పుడు జస్ట్
Sir, can I start the session, sir?
You can start, Andy.
Okay.
Sir is there?
Yes, sir.
Okay, you can start.
Good morning to the esteemed speaker of today's session, Principal Dr. A. Lakshman Rao Garu, participants of various colleges, myself Manasa, Assistant Professor, Department of Pharmacology. On behalf of VV Institute of Pharmaceutical Sciences, excited to welcome you all to day 1 of 1 week online faculty development program on cell therapy, pharmacological insights and future directions, organized by VV Institute of Pharmaceutical Sciences, Gudlavalleru. Light symbolizes the knowledge, purity, and divine presence. If you light a lamp for someone else, it brightens your path also. Now we have our traditional lamp lighting ceremony.
कल्याणम् आरोग्यं धनसम्पदः शुभं कुरुत्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः
Let's begin the session with traditional auspicious prayer song.
या कुन्देन्दुतुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्कर प्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमाम् आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीमभयदां जाड्यान्धकारापहा हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थिता वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदा
I welcome Patron Dr. A. Lakshman Rao sir, Professor and Principal of VV Institute of Pharmaceutical Sciences. Now I would request Dr. A. Lakshman Rao sir to speak a few words about today's session.
Pavan Kumar garu, how are you andi? Madam Sadis there?
Yeah.
Yes, sir.
Sir, good morning, sir. I am fine, sir. I am fine, sir. How are you, sir?
Fine, and thank you. Thank you very much for accepting our invitation.
Thank you, sir. Thanks for inviting me for this session, sir.
Shall we continue?
Yes, sir. Yes.
Okay, thank you, Andy. Eminent speaker of the today's session and my good friend Dr. S. Pavan Kumar garu, Head Department of Pharmacology, Sri Vishnu College of Pharmacy, Vishnupur, Bhimavaram, Andhra Pradesh. Participants from various pharmacy colleges. A very delightful morning to one and all. I open 1 week online faculty development program on cell therapy, pharmacological insights and future directions, organized by VV Institute of Pharmaceutical Sciences, Gudlavalleru, from 9th to 14th December 2024. I'm happy to inform you that our college, VV Institute of Pharmaceutical Sciences, was sponsored by AANM and VVRSR Education Society, Gudlavalleru, Krishna District, Andhra Pradesh, in the year 2010, and running with both BPharm as well as the MPharm pharmaceutical analysis programs. And our is one of the premier institute in pharmacy education in the state of Andhra Pradesh. Our institution is approved by Pharmacy Council of India, New Delhi, and approved by JNTUK, Kakinada. Our college was accredited by NAC and ISO 9001-2015 certified institution. I proudly announce that our institution, VV Institute of Pharmaceutical Sciences, Gudlavalleru, is conducting this 1-week online faculty development program for 6 days with 6 lectures by 6 eminent speakers in the area of the pharmacology. The major objectives of online faculty development program on cell therapy, pharmacological insights, and future directions is generally the cell therapy has emerged as a promising treatment modality offering potential cures for a variety of diseases, including mainly cancer as well as genetic disorders and degenerative conditions. The therapeutic approach utilizing living cells to repair or replace damaged tissues, enhance the immune responses, or modulate the disease pathways. And pharmacological insights into cell therapy are essential to optimize cell behavior and improve the engraftment and ensure safety. Key challenges include immune rejection, thermogenicity, and scalability. Future directions in cell therapy involve advancements in genetic engineering, biomaterials, and personalized approaches, which could enhance the efficacy and provide sustainable, targeted treatments for complex diseases. Participants will gain actionable strategies for addressing current challenges and future directions in the area of cell therapy. My heartiest acknowledgements to the members of the management, Dr. V. Nageshwar Rao, Chairman, Sri M. Srinivas Rao, Co-Chairman, Sri V. Satyanarayana Rao, Secretary and Correspondent, and Sri V. Ramakrishna, Co-Secretary and Correspondent, and Sri V. Subbarao, President, Sri K. V. Krishna Rao, Vice President of AIM and VVRSR Education Society and VV Institute of Pharmaceutical Sciences for their generous and continuous support for the development of institution. I especially thank Dr. Sri Kaminabi and Head Department of Pharmacology and FDP's coordinator VVIPS for her planning of this FDP event. I profusely thank my colleague Ms. G. Manasa, Assistant Professor and convener of this 1-week online faculty development program, for her enthusiasm for conducting this particular program. I strongly believe that this 1-week online faculty development program will become astonishing event, and I wish all the participants will gain wide knowledge on emerging areas of pharmacology, which will be beneficial for all the faculty members of the pharmacy fraternity also. I am very happy to inform you that totally 100 teacher participants. We restricted to 100 only due to Zoom limit, and total all the 100 teacher participants were registered from various pharmacy colleges. Nearly more than 50 pharmacy colleges were registered across the India. Thank you all for your active participation and interest towards pharmaceutical education and research. I request all the participants to attend all the 6 days plenary lectures, and you will gain the good scientific knowledge also. In day 1, Dr. S. Pavan Kumar Garu is a senior academician, and he will deliver a lecture on the novel role of PPRs in the brain, promising target therapy in neurodegenerative diseases. Now I hand over to Dr. G. Manasa, convener for faculty development program, to introduce the today's speaker to the participants. Thank you, Anandal. Over to Manasa Garu.
Thank you, sir. We are very grateful for your insightful words, sir. It gives me an immense pleasure to introduce today's speaker, Dr. Pavan Kumar Samudrala, sir, an esteemed academician currently working as Associate Professor, Department of Pharmacology at Sri Vishnu College of Pharmacy, Bhimavaram, Andhra Pradesh and India. Dr. Pavan Kumar, sir, is an accomplished researcher and educator specializing in pharmacology, with a particular focus on neurodegenerative diseases such as Parkinson's and cognitive impairments. He holds a PhD in pharmacology and toxicology and has extensive experience in investigating the underlying mechanisms of these diseases, including oxidative stress, inflammation, and apoptosis. His research explores both plant-based and synthetic compounds for their potential in treating neurodegenerative disorders, with a special emphasis on Ayurvedic medicine and neuroprotective formulations. Sir currently serves as an associate professor at Sri Vishnu College of Pharmacy after previously holding an academic positions at Naipur, Guwahati and Annamacharya College of Pharmacy. His research contributions include over 20 publications in prestigious journals, with recent work on the effects of saroglitazar on neurotoxicity, the use of montelukast in Alzheimer's disease, and the application of silk fibrion scaffolds in diabetic wound healing. Beyond his research, he plays an active role in academic and industry collaborations, consulting on neuroprotection projects and serving on animal research ethics committees. He has also filed patents for innovations in herbal based products and chemical synthesis. Through his research and academic endeavors, Sir continues to make significant strides in advancing the understanding and treatment of neurodegenerative diseases. Now I would like to invite Dr. S. Samudrala Pavan Kumar sir to hand over a session. Thank you, sir.
Yeah. Thank you, madam. Thanks for the nice introduction. Thank you, Principal Sir, for inviting me for this auspicious faculty development program. Thank you, sir. Yeah, with this brief introduction, I would like to start the session. So, as it is faculty development program, so I thought it will be helpful for the I'm sharing my thoughts in my research, especially on the neurodegenerative diseases. So, as it is faculty development program, so many faculty maybe they are pursuing, maybe they are interested to do PhD, maybe they are trying to they are maybe in mid position of the PhD, or maybe they are pursuing their PhD. So in that way, I would like to concentrate on how to design work for the PhD. So in this way, I'm planning to deliver the lecture. So for example, whenever we are planning for the PhD, or whenever we have registered for the PhD, so many people, so many faculty, they are in the confusion that how I have to select the topic, in which way I have to conduct my research. So these are the n number of doubts they used to have in their crucial, in time of PhD things. So whenever we are doing PhD, so whenever we are concentrating on the PhD, so our ultimate goal is that so here, how to select the topic. So as we are from the pharmacology, so whenever you are selecting the PhD, so nowadays, those days has gone, take some plant extract and do randomly some activities and publish the paper. So slowly those dates are extending. So nowadays, we need to focus on the targets. So we need to focus on the what are the different targets are involving in the diseases. So please, whenever you are choosing the PhD program, whenever you are selecting the some topic for the PhD, so please focus on the various pathways or various targets involving in that particular disease. So first focus on one disease and start digging the literature that what are the different targets are involving in that particular disease. So when once your target got fixed, then start selecting the drugs based on that particular target. So first level of selection is the first select your disease, then go to the review of literature and start selecting the targets. What are the different pathways are involving in that particular disease, and what are the main targets are involving in that particular disease. So first one is the disease, next one is the target. Third aspect is the based on that particular targets, see the various drugs. So already maybe some class of drugs already reported in that reported, and we may get some literature that so and so drug it will work on that particular target. So please try to select the drugs based on the target, then go for the experimental design. So once as it is the pharmacology related FTP, I am trying to say is that so you can include like in silico analysis, in vitro, as well as the in vivo. But whenever you are from the pharmacology, then try to focus more work related to the in vivo pharmacology. So whenever we are designing the in vivo pharmacology, so like animal related pharmacology, so at least we need to select our experimental design in such a way that if there are any behavioral parameters, go for the behavioral parameters. Then try to include some biochemical parameters like antioxidant assays. Then based on the target, so whatever the target we have selected, that particular target related biomarkers. So to analyze that particular biomarkers, we can go for the ELISA, or we can go for the Western blotting, or we can go for the RT-PCR. Then after analyzing all this like behavior, biochemical, then target related research, then we need to provide some proof at the level of the cell. So for that, it is essential to include the some histopathological aspects. So in case of histopathology, we can go for the hematoxylin eosin staining or mesenteric staining, or if we have the, but if budget can permits, then even if it will go for the IH immunohistochemistry, that will be more useful. So this is the like fourth or fifth aspect while designing our the PhD. So after designing the project, now like we will conduct the study, then we will get the results. Then this is the crucial part, analysis of the results. So many, like I have seen so many like faculty or so many students are like they used to depend for the statistical analysis on some other faculties. So please try to learn the statistical analysis. Nowadays, so many tools are available to analyze the data. So for that, we can go for the tools like GraphPad Prism is the one of the best tool to analyze the statistics. So we can use tools like GraphPad Prism, or we can go for the SPSS. So this is for the statistical analysis. Then we will generate the data. Then after that, we will complete our drafting, like then we need to go for the drafting the paper. So for the like nowadays, like to award the PhD in any universities like state universities or central universities or deemed to be universities, essential criteria is at least to try to publish the two indexed papers. It may be Scopus indexed paper or Web of Science indexed paper. So that is our selection of the journal is the next criteria. So that is now like what is happening, like we are spending so much time for designing the project, for execution of the project, for analyzing the data, and also for writing the paper. Maybe we may take 1 year to 1 to 2 years. We will spend time on this particular thing. For selection of the journal, like nowadays, what is happening? Like so many fake journals has come, cloned journals has come. So they are showing that it is indexed in the Scopus or it is indexed in the Web of Science. But the truth is that with one journal, they are cloning the another journal, and with they are opening some false website. We are early to the research, so many people, they're not looking that much, they're not doing extensive research in that, so people are publishing their valuable research in the cloned journals. So please, so this is my sincere request, whenever you are updating, whenever you are uploading the paper into the journals, please be sure that whether it is original journal or cloned journal. Why I am stressing, why I am emphasizing this thing is like so many nowadays, so many of my friends or so many of my students, they're experiencing this kind of situations. So please, while uploading the paper, so please make sure that whether you are uploading into the correct journal or cloned journal. Okay, so that is the like these are the different steps are involved in the PhD work. So selection of the disease, selection of the target, then selection of the drug, then experimental design, then executing the work, then analyzing the data, drafting the paper, and communication of our paper. So with this brief introduction, I would like to start my session. So like I will share my experiences, how like we are executing our work in our lab. Okay. I hope my PPT is visible.
Yes, sir.
Yes, sir.
Yeah, thank you. So, so here I would like to share my experience or my research with you people. So, like currently, I have explored the role of PPARs in the neurodegenerative diseases, especially it is in Alzheimer's disease as well as the Huntington's disease. So, as time is limited here, just I would like to share my experiences with the PPR agonist in case of the Alzheimer's disease. So, as I said, like first step is the selection of the disease. So, here I have selected the Alzheimer's disease for my students' research. So, why I have selected Alzheimer's is, so Alzheimer's is like as per the data, like if you will see WHO report, World Health Organization report, or if you will see the Center for Disease Control and Prevention CDC data, Alzheimer's disease is one of the most devastating neurodegenerative disorders in the older adults. So currently, as per the report of the 2017, in the world, 50 million people are affected with the Alzheimer's disease. And also this particular disease prevalence is rising to 82 millions by 2030, and it may be go 150 millions in the year of 2050. And as per my personal experience, as per the current experience, I can say that this particular data, not only 150 millions, it may go to the 200 millions, because nowadays, so many of reports are coming that digital amnesia. So because of the extensive use of the gadgets, so we are losing our memory very drastically. Previously, when we will say Alzheimer's disease, maybe the people who are age more than 60 years, maybe they are more prone to experience the Alzheimer's disease. But currently, because of these particular gadgets, because of the digital usage of the digital tools, even at the age of the 40 years itself, people are experiencing the amnesia. So this particular prevalence rate, maybe it may reach 200 millions also in the 2050. So that's why, because of these reasons, I have selected the Alzheimer's disease for my students' research topic. So, what is Alzheimer's disease? So, in case of the Alzheimer's disease, if you will see, so this is the size of the healthy brain size. And in case of the Alzheimer's, if you will see, the brain is the shrunken when compared to the healthy brain size. So, why this particular shrunken brain is happening in case of the Alzheimer's disease is so these are the different parameters, different biomarkers are involving in the Alzheimer's disease. So if you will see the cellular targets or molecular biomarkers, especially this Alzheimer's disease, it is in case of Alzheimer's disease, cognitive impairment is taking place. So our entire cognitive system is mainly regulated by the hippocampus, especially the neurons which are involving in the hippocampus, that are like cholinergic neurons. So cholinergic neurons plays important role in the memory formation. So once this particular cholinergic neurons will get damaged, slowly our memory will get impaired. Not only memory, it also lead to the damage of our intellectual skills, judgment skills, and also we lost how to respond to the environmental cues. All these features we will observe in case of the Alzheimer's disease. So here in case of the Alzheimer's disease, mainly what is happening is loss of cholinergic neurons, especially in the hippocampus region, as well as some extent maybe in the prefrontal cortex region. So why this particular neurodegeneration of the neurons is happening, degeneration of the cholinergic neurons is happening, means because of the formation of the amyloid beta plaques, formation of the beta plaques, as well as the neurofibrillatory tangles. So these are the two culprits for the damage of the neurons. One is the beta amyloid plaques, another one is the formation of the neurofibrillatory tangles. If we will see this amyloid beta plaques, they used to form extracellularly, and the neurofibrillatory tangles, they used to form intracellularly. Intracellular formation of the neurofibrillatory tangles, as well as the extracellular formation of the amyloid beta plaques. These two things together, what they will do means they will promote the oxidative stress, as well as they will also promote the inflammation. So this inflammation as well as the oxidative stress, further it will promote the apoptosis, and it lead to the loss of cholinergic neurons in the hippocampus. So because of the loss of cholinergic neurons in the hippocampus, there is a drastically reduced synthesis of acetylcholine. Then this particular reduced acetylcholine, it couldn't able to bind with the muscarinic receptors, and there is no formation of the synaptic plasticity, and it lead to the Alzheimer's disease. So main thing is the beta amyloid plaques, neurofibrillatory tangles, oxidative stress, neuroinflammation, apoptosis. So these all are the different markers or different markers involving in the generation of the Alzheimer's disease. So these are the various etiological factors for the Alzheimer's disease. So one is the mitochondrial dysfunction, tau hyperphosphorylation, it is forming the neurofibrillatory tangles. Another one is the amyloid beta plaques. Then already I have informed in my previous session that formation of the beta amyloid plaques as well as the tau hyperphosphorylation, it is damaging the cholinergic neurons. So because of the damage of the cholinergic neurons, there is no proper synthesis of acetylcholine. It is leading to the cholinergic insufficiency, as well as the neuroinflammation, oxidative stress. All together they are leading to the Alzheimer's disease. So in this way, I have proposed my introduction for the research. Then, if you will see the current targets, currently, we have the drugs like tacrine, galantamine, donepezil. These are the different drugs are available for available to treat the Alzheimer's disease. So all these drugs, they are mainly concentrating on the cholinergic influence by inhibiting the enzyme, as everyone knows that cholinesterase enzyme. By inhibiting the cholinesterase enzyme, it is increasing the levels of the acetylcholine. So that is the only target. So, but there is a now it is the time to develop the alternative strategies to mitigate the Alzheimer's disease. If you will concentrate only on the cholinergic neurons, it will not be sufficient. Now, whatever the targets we have to choose, that particular target has to work on the amyloid beta plaques, and also that particular target has to work on the oxidative stress, and also that particular target has to work on the inflammation. So if any target, if it can able to mitigate formation of the amyloid beta plaques, formation of the neuroinflammation, and also oxidative stress, and if it can able to inhibit the apoptosis, then that particular multi-target therapy will be helpful to mitigate the progression of the Alzheimer's disease. So when we are in this particular direction, then we found that two targets, that is the PPRs, peroxisome proliferator activated receptors. So these receptors, we found connection with these particular receptors with the neurodegenerative diseases, especially like PPR alpha as well as the PPR gamma. These both receptors, they are having connection with the Alzheimer's disease. So when we have seen the literature, when we have dug out the literature, we found that the levels of PPRs alpha as well as the gamma, they are drastically decreased in the diseased brain. That is like Alzheimer's disease brain, this particular PPR alpha as well as the PPR gamma drastically decreased. So this was the surprise we found during our literature. Then we thought that, okay, so if we can able to upregulate or we can able to stimulate this particular receptors, then that may be the best target to treat the Alzheimer's disease. So that was our hypothesis. Then later we also found that PPR alpha as well as the PPR gamma, they also have their role in treating the or to regulate the mitochondrial dysfunction as well as the oxidative stress as well as the neuroinflammation in case of the Alzheimer's disease. So if you will see like so this is normal regular physiological PPR alpha agonist as well as the PPR gamma agonist, already they are in the market to treat the various disorders. PPR alpha agonist like fibrates, clofibrate, fenofibrate, gemfibrozil. So already they are in the market to treat the hyperlipidemia, as well as the PPR gamma agonist, thiazolidinones. They are already available in the market to treat the diabetes. So this PPR alpha as well as the PPR gamma, they will belong to the nuclear receptors, especially type 2 nuclear receptors. So whenever ligand will bind with the PPR receptors, then as it is the nuclear receptors, always they used to bind with the nucleus, especially DNA. Then it will activate the DNA. Then PPR alpha as well as the PPR gamma responsive genes will be expressed. Then it lead to the synthesis of RNA. Then it lead to synthesis of the proteins. So this is the molecular mechanism involving in the PPR alpha agonist as well as the PPR gamma agonist. Then this is the new pathway, or this is the new things we found from the literature that in the Alzheimer's disease, in the brain of the Alzheimer's disease, we have seen that the levels of PPR alpha as well as PPR gamma has drastically reduced. So this PPR alpha as well as the PPR gamma, because of the reduction of the PPR alpha as well as the PPR gamma, there is a, if you will see, this reduction of the PPR alpha levels, it is leading to the increased secretion of the base enzyme, increased expression of the base enzyme. So this is the base enzyme. Base, it is also called as the beta secretase enzyme. Base, it is also called as the beta secretase enzyme. This beta secretase enzyme is playing enormous or critical role in the cleaving of the amyloid precursor protein. So this is the amyloid precursor protein, main culprit of the Alzheimer's disease. So this amyloid precursor protein is cleaved by the beta secretases. Whenever beta secretases will cleave the amyloid precursor protein, then it lead to the formation of the amyloid beta oligomers. These amyloid beta oligomers further they will form into the amyloid plaques. These amyloid plaques further they will promote the neuroinflammation and it lead to the neurodegeneration of the cholinergic neurons. So whenever the levels of the PPR alpha as well as PPR gamma is reduced, then they are promoting the expression of the beta secretase enzyme, that is the base enzyme. So whenever beta secretase enzyme expression is increasing, then it is leading to the more synthesis of the amyloid beta and it is leading to the degradation or degeneration of the cholinergic neuron. So this is one of the best target in the Alzheimer's disease, and this particular target is validated also in the Alzheimer's disease. So we have established the link between the beta secretases as well as the PPR alpha as well as PPR gamma in the brain. And also, if you will see further that PPR alphas, so it can able to inhibit the oxidative stress and also it can able to inhibit the neuroinflammation and also it can able to inhibit the beta amyloid plaques formation. So PPR alpha. So now we have established the thing that now it is having the multi-role. It can able to target all the markers which are involving in the development of the Alzheimer's disease. So if we can able to activate this particular PPR alpha receptor, we can inhibit oxidative stress, we can inhibit neuroinflammation, we can inhibit the formation of beta amyloid plaques. So this was the hypothesis we have developed for our research. Later we have also seen the role of PPR gamma, especially this PPR gamma, it will increase the levels of the BDNF. So BDNF, this is one of the main marker whenever we are doing research in the neuro. So BDNF, brain derived neurotrophic factor. So these neurotrophic factors, they will help for the formation of the synaptic plasticity, as well as they will help for formation of the memory. So if any drug, if it can able to increase the levels of BDNF, then that particular drug will be useful to treat the Alzheimer's disease. So surprisingly here, PPR alpha as well as PPR gamma, they also have role to upregulate the or to able to synthesize the BDNF. So with all these things, so like we have disease, Alzheimer's disease, then our target is the PPR alpha as well as the PPR gamma. So if any agent which can able to activate PPR alpha as well as PPR gamma may have the neuroprotection against the Alzheimer's disease. So this was our hypothesis. Then we have searched the market. So what are the drugs available to stimulate the PPR alpha as well as the PPR gamma? Then we found that the drug saroglitazar. So this is the dual. It can able to activate both PPR alpha as well as the PPR gamma. So that's why we have selected the drug saroglitazar to execute our research. So this is our study design. So whenever we are conducting any study with respect to pharmacological study, in vivo pharmacological study, so always we will keep normal control, then disease control. So here we have selected, as we have selected Alzheimer's disease, so we have to develop the Alzheimer's model. So to develop the Alzheimer's model, various drugs are available to develop the Alzheimer's disease, like aluminum chloride model is available, or otherwise directly induction of the beta amyloid plaques, or otherwise scopolamine model is also there. And also directly we can take the transgenic animals also we can take. So as we do not have the we do not have the facility to maintain the transgenic animals, we have selected the chemical induced models only. So in case of chemical induced models also, there are aluminum chloride model, beta amyloid plaques model, then scopolamine model is available. Among those three, we have selected the scopolamine model because of its advantages when compared to other models. We have selected the scopolamine model. So to induce the Alzheimer's disease, we have used 3 mg per kg scopolamine dose. Then also, as a standard, we have taken the donepezil, and for saroglitazar, based on the previous literature, we have selected the 10 mg per kg as the dose for the saroglitazar. So in each group, we have included the 6 number of animals. So this is our experimental design to execute this particular or to prove this particular hypothesis. So this is our brief experimental design. So we have conducted this particular study for the 16 days. So initial from day 1 to day 7, this is the pre-treatment with the saroglitazar. During this particular 7 days, we have administered our drugs only with the saroglitazar. Then from day 8 to day 16, we have given simultaneously scopolamine as well as our drug saroglitazar. Simultaneously, we have administered both the drugs. So as previously I have mentioned that to prove our hypothesis, we have to conduct some behavioral test. If available, we have to go for some behavioral test. Then we have to go for some biochemical test. Then we need to go for the validation of the markers. Means like we need to analyze the markers which are involving in the Alzheimer's disease. Then we need to go for the histopathology. So here also same thing we have done from day 8 to day 16. We have conducted different behavioral tests related to memory. So those are like novel object recognition test, PIMS test, Morris Water maze test. So these are the different tests we have performed. Then after completion of this particular Morris, all the behavioral tests, then we have subjected for the euthanasia. Then we have collected the brain sample. From the brain, we have isolated the hippocampus. Then we subjected for the homogenization of the hippocampus. Then we went for the estimation of the various antioxidant parameters like MDA, like melanodialdehyde, reduced glutathione, superoxide dismutase, nitric oxide, and also specific markers. As previously I have discussed, amyloid beta plaques, this is the main culprit for the development of the Alzheimer's disease, and also BDNF, this is the neurotrophic factor. It is very much essential for the formation of the synaptic plasticity as well as the memory formation. So that's why we have estimated the levels of the BDNF as well as the amyloid beta. and also inflammatory marker, that is the nuclear factor kappa beta. So we have estimated all these particular biochemical markers as well as the antioxidants in the hippocampus. And also we have subjected hippocampus samples for the histopathology also. So this is the after completion of our study, we need to analyze our data. To analyze the data, we have used the GraphPad Prism. So I found this is very user-friendly software. This is the best one, especially for the pharmacological data. So if we do not have the GraphPad Prism, then also we can also analyze our data by using the SPSS also. So these are the best available software tools currently available in the market. So this is about the open field test. By using the open field test, we can determine the locomotor activity of the animals. So by using, we have the software, NMS software we have. So by using the NMS software, we have performed the open field test. So in case of open field test, we will divide our maze into 16 squares. So here we will see how many squares, each group of animals they are subjected for this particular test. Then at last we will compare the data. So here we are measuring the number of crossings, distance traveled by the animal, time spent in the central squares, time spent in the peripheral squares. Of course, time spent in the central squares as well as the peripheral squares, it is mainly helpful for the anxiety related experiments. It is not that much required for when we are dealing with the behavioral test. So these are the results we have observed from the open field test. Then after that, we have performed another test, that is the novel object recognition test. This novel object recognition test, mainly it is divided into 3 phases. That is the habituation phase, training phase, testing phase. So maybe as we are having the limited time, it is not sufficient to discuss in detail about all this particular test. So in brief, I am saying that in habituation phase, first what we are doing here. So this is the prototype of the novel object recognition test maze. So here, in case of habituation phase, just we are exposing animals to that particular maze. That is the first day. On second day, we have divided our experiment into 2 phases. That is, one phase is the training phase, another one is the testing phase. In case of the training phase, we are keeping 2 identical objects. And we will expose our animal to these particular objects for the 8 minutes. Then after completion of the 8 minutes, we will give 1 hour break. Then after 1 hour, we will replace one of the old object with the novel object. So as per the tendency, if animal is having the memory, then it will spend more time with the novel object. If it doesn't have the memory, then it will spend, or it may spend the equal time with both the objects, or it may spend more time with the old object. This particular objective, we have performed the novel object recognition test. So here, parameter is the discrimination index we are measuring here. So this is the formula to measure the discrimination index, time spent at the novel object divided by the time spent at old object as well as the novel object. So all this particular information you can get from my papers, as you can get from the Google also, you can get it, all this particular information. So this is the data what we have generated from the novel object recognition test. Then we have done the YMS test. YMS test we are using to evaluate the short-term memory test. We are using the YMS test. So in case of the YMS test, we are measuring the percentage spontaneous alterations. So this is the YMS test. Here we are measuring the percentage spontaneous alterations. So if you will see, this is the YMS test. So this is the video from the YMS test. So we'll see this YMS, it is in the shape of the Y, and it is divided into 3 arms. Arm A as well as the arm B as well as the arm C. So whenever animal is entering into the alternative arms, that is first animal arm A, then arm B, then if it will enter into the arm C, then we will consider this particular thing as a alterations. So we will consider A, B, C. This is one triad, and we will consider it as a one alteration. So here we will measure the number of alterations. Number of alterations divided by the total number of entries minus 2. If whenever this number of alteration, in case of the Alzheimer's disease, number of alterations used to be reduced. Animal cannot able to differentiate between the already existing arm as well as the new arm. So that's why animal, after exploring the arm A, then we enter into the arm B, then again it will forget, again it may enter into the arm A. So that's why number of alterations used to be drastically decreased in case of the Alzheimer's animals. So this is the data what we have generated from the YMS test. Then at last we have performed the water maze test. This is one of the gold standard tests for the Alzheimer's disease. So this particular Morris Watermills test we have done approximately for the, so this is based on the standardization. In few labs they may conduct for 5 days, in few labs they will conduct for the 6 days. In our lab we have conducted for the 3 days. So in these 3 days main test, then on fourth day we have conducted the probe analysis also. So total we have conducted for the 4 days. So here these are the parameters: escape latency, and in case of the probe test, like escape latency means how much time it is taking to reach the platform. So this is the escape latency. Then in case of the probe test, we are calculating the time spent in the target quadrant. So in case of the probe test, we will remove the probe from the target quadrant and we will measure the amount of the time spent by the animal in the target quadrant. And also number of crashings also we will measure in the probe test. So in first evaluation phase, we will measure the escape latency. In probe analysis, we will measure the time spent in the target quadrant as well as the number of crossings in the target quadrant. So if you will see, this is the water mesh. We will divide this particular mesh into the 4 quadrants. So this is one phase, first quadrant, second quadrant, third quadrant, and fourth quadrant. In any one of the quadrant, we will place the platform. So, and we will measure that. So we will, for example, like if we will place animal in one quadrant and we will measure the time to reach the platform. Here we will measure how much amount of the time animal is taking to reach the platform. That is the escape latency. If animal is having the memory, then, sorry, 1 minute. So if animal is having memory, then within a short span of time, it can able to reach the platform. If doesn't have the memory, then it will search for this particular platform and it will take the more time. So this is the parameter what we are measuring in the Morris Watermills test. So in case of escape latency, if animal is having the good memory, it will take very less time to reach the platform. If animal doesn't have memory, if animal is suffering from the Alzheimer's disease, then it will take more time to reach the platform. Then on fourth day, we will remove this particular platform. That particular test is called as the probe analysis. So after removal of then if animal is having memory, then what it will do, it will come to this particular quadrant and it will search for the platform. So that's why what we will measure in case of the probe test is the how much time animal is spending in the target quadrant. Why it is spending more time in the target quadrant? That if it is having memory, it know that yes, platform is available in this particular target quadrant. So that's why it will explore only in this particular quadrant for the platform. So that's why we are measuring the time spent in the target quadrant, as well as the number of crashings also we are measuring in the probe analysis. So this is the Morris Watermills test. So this is we are divided this particular mesh into the 4 quadrants. So if you will see, this is the target quadrant. So we placed our platform in this particular quadrant. See, so here we are measuring the how much time animal is taking to reach this particular platform. So this is the escape latency. In fourth day, we are removing the particular platform. Then also if they will spend in same quadrant, then we can say that animal is having the memory. So for example, if you will see this particular statistical data, time spent in the target quadrant, normal control animals, they are spending more time in the target quadrant. If you will see the diseased animals, the animals which are suffering from the Alzheimer's disease, means the animals which were treated with the scopolamine, they are spending significantly less time in the target quadrant when compared to the normal control animal. So it is denoting that these animals are suffering from the Alzheimer's disease. So whenever the animals were treated with the respective treatments, like maybe donepezil or maybe treated with the saroglitazole. So if you will see the saroglitazole treatment group, they are spending more time in the target quadrant when compared to the disease control group. It is saying that this particular saroglitazole treatment group is having the significant neuroproduction activity against the scopolamine-induced Alzheimer's disease. So, and also if you will see the escape latency also, distance traveled as well as the escape latency. If you will see, this is the disease group. So disease group is taking more time to reach the platform. See, this is the disease group, this particular disease group is taking too much time to reach the platform when compared to the normal control group. It is denoting that yes, these particular animals are suffering from the memory loss. They are suffering from the Alzheimer's disease. So that's why they doesn't have the memory. So it doesn't remember. It doesn't able to recall where that particular platform is locating. So that's why it is taking too much time to reach the platform. At the same time, if you will see the treatment group, the animals which were treated with the saraglitazar, they have the memory. So that's why they are reaching the platform within the 15 seconds itself. It is reaching the platform. So we can say that based on this particular water mist test, we can say that this particular saraglitazar treated group is having the memory. So after completion of the behavioral test, then we have conducted the biochemical test as well as the histopathology test. So for that, we have sacrificed the animal. Then we have harvested the brain. From the brain, we have isolated the hippocampus. Then this particular hippocampus, some part of the hippocampus, we subjected for the histopathology, and half of the hippocampus, we went for the homogenization and we prepared the homogenate, and we have estimated the various biochemical parameters in that particular homogenate. So this is so as we all are aware that acetylcholinesterase enzyme, this is the metabolic enzyme. It can able to cleave the acetylcholine. So in case of the Alzheimer's disease, the levels of acetylcholinesterase enzyme is very much elevated. If you will see this particular results. So in case of the animals which are suffering from the Alzheimer's disease, in those animals, the levels of acetylcholinesterase enzymes are very much elevated. Whenever acetylcholinesterase enzymes are elevated, it is saying that if acetylcholinesterase enzyme levels are more, then it can able to break down the acetylcholine. Then very less amount of the acetylcholine is available in the brain, then that acetylcholine is not sufficient to form the memory as well as the synaptic plasticity. It is leading to the cognitive impairment. So that's why we have estimated the levels of acetylcholinesterase in the brain as well as we have estimated levels of acetylcholinesterase in the hippocampus as well as the plasma. So in the animals which were treated with the scopolamine, the levels of acetylcholinesterase enzymes were significantly elevated when compared to the normal control group. However, the animals which were treated with the saraglitazar having significantly decreased amount of the acetylcholinesterase enzyme we have observed. So it means that acetylcholinesterase saraglitazar is having ability to inhibit the acetylcholinesterase enzyme. So if we can able to inhibit the acetylcholinesterase enzyme, then there is no breakdown of the acetylcholine. Then in the body, the levels of acetylcholine will be maintained. That acetylcholine will be sufficient to form the synaptic plasticity as well as the formation of the memory, and we can protect that particular animals as well as the humans from the Alzheimer's disease. Then after that, we have also estimated the various oxidative stress markers like SOD as well as the GSH. So in our study, in our research, the animals which were treated with the saraglitazar elevated the levels of the reduced glutathione. This is the antioxidant enzyme. It can able to neutralize the free radicals. So it is showing that this particular results, they are showing that we can able to protect the brain from the free radicals. So at the same time, we have also estimated the oxidative stress markers like MDA as well as the nitric oxide. So in the brain, the levels of the oxidative stress markers like melanodialdehyde, lipid peroxidation marker. This is the lipid peroxidation marker is the MDA. The levels of MDA as well as the nitric oxide were significantly elevated in the hippocampus. So it is saying that these elevated oxidative stress markers, they can able to damage the hippocampus. This damaged hippocampus, further it is leading to the formation of the neuroinflammation, and also it can able to promote the apoptosis, and it can able to lead to the Alzheimer's disease. But however, the drug saraglitazar, it can able to inhibit or it can able to attenuate the levels of the melanodialdehyde as well as the nitric oxide. In this way, we can neutralize the oxidative stress in the brain, and we can protect our brain from the oxidative stress markers. Then after that, we went for the specific marker analysis by using the ELISA. So as per the introduction, I already explained that the levels of the amyloid beta as well as so here various ELISA techniques are available like direct ELISA, indirect ELISA as well as sandwich ELISA. Here in our analysis we have used the sandwich ELISA. So by using this sandwich ELISA, this is the procedure for the sandwich ELISA. So I'm not going to explain in detail about the sandwich ELISA. So here we have estimated the levels of BDNF as well as the beta amyloid plaques. And also we have estimated the oxidative stress marker, that is the intrinsic nitric oxide synthase. So beta amyloid plaques. These are the beta amyloid plaques are generating from the amyloid precursor protein with the help of the enzyme that is called as the base. As in case of Alzheimer's disease, the levels of base is extremely elevated. It can able to cleave the amyloid precursor protein and it will form the beta amyloid plaques. So same thing is happening in our model also. So whenever animals were treated with the scopolamine, in those animals, whenever we have estimated the beta amyloid plaques, the levels of the beta amyloid plaques were significantly elevated when compared to the normal control group. It is saying that there is a extensive formation of the beta amyloid plaques. These beta amyloid plaques further they cause the neurodegeneration in the hippocampus. So whenever, like after treating our animals with the saroglitazar, so they have the ability to downregulate the base enzyme. So because of the downregulation of the base enzyme, it cannot able to cleave the amyloid precursor protein. If there is no cleavage of amyloid precursor protein, then there is no synthesis of beta amyloid plaques. So same thing we are observing in this particular analysis also. So saroglitazar, the drug saroglitazar is having ability to regulate the cleavage of the amyloid precursor protein. In that way, the levels of beta amyloid plaques were significantly reduced in the treatment group when compared to the disease control group. At the same time, we have also estimated the levels of the BDNF. This is the brain-derived neurotrophic factors. So these brain-derived neurotrophic factors, they play important role for the formation of the memory as well as for the synaptic plasticity. So here, because of the formation of the beta amyloid plaques in the disease group, it can also downregulate the synthesis of BDNF. So that's why if you will see in the scopolamine group, the levels of BDNF were significantly decreased when compared to the normal control group. So it is saying that synaptic plasticity is significantly hampering in the disease control group. Because of the hampering of the synaptic plasticity, there is no formation of the memory, and these animals are suffering from the Alzheimer's disease. So the animals which were treated with the saroglitazar, they can able to they can able to promote the formation of the brain-derived neurotrophic factor. So once the levels of brain-derived neurotrophic factors were get elevated, then they can able to improve the synaptic plasticity, then they can able to improve the memory formation. So in our study also, saroglitazar treatment group, the levels of BDNF were significantly increased when compared to the scopolamine alone treated group, that is disease group. So saroglitazar, the PPR alpha as well as PPR gamma agonist, it is having ability to upregulate the BDNF as well as downregulate the beta amyloid plaques. So as beta amyloid is decreasing, BDNF levels are increasing. We can say that the drug is having the neuroprotection activity against the scopolamine induced disease animals. To confirm further, and also we have estimated the neuroinflammation markers also, like neuroinflammation markers like NF-kappa beta as well as the TNF alpha. Here also we are observing same pattern. In the animals which were treated with the scopolamine, like in Alzheimer's disease animals, the levels of NF-kappa beta as well as the TNF alpha levels were significantly elevated when compared to the normal control group. However, after treating with the saroglitazar, the levels of NF-kappa beta as well as TNF alpha were significantly decreased when compared to the disease control group. It is saying that from this particular experiment, we can say that saroglitazar, it is having ability to inhibit the neuroinflammation. So now we have, like, from based on our hypothesis, by conducting the experiments, we are proving that saroglitazar, it is having ability to inhibit the inflammation, it is having ability to inhibit the oxidative stress, and also this particular saroglitazar, it is also inhibiting the levels of amyloid beta, and also it is increasing the levels of BDNF. So from all these markers, we can say that the saroglitazar, it is having effect against the scopolamine-induced Alzheimer's disease. Then to further confirm these particular markers, we have also subjected for the Western blotting. So in Western blotting, so this is the brief protocol involving in the Western blotting. So itself, it will take a lot of time. So that's why I'm not explaining the protocol. You can refer some sites for the procedure of the Western blotting. So here we have estimated the levels of base enzyme. We have estimated the levels of base enzyme. So Western blotting mainly we will use to see the expression of the protein markers. So for that, we have estimated the level to see the expression of the base protein as well as NF-kappa beta protein, BDNF protein. Here in all Western blotting procedures, beta-actin is the housekeeping protein. We will use beta-actin as a standard one. So if you will see BDNF, the levels of BDNF, in case of the disease group, the levels of BDNF is significantly decreased when compared to the normal control group. However, after treating with the saraglitazar, the levels of the expression of the proteins were significantly increased when compared to the disease control group. And also, if you will see the base enzyme, it is also called as the beta secretase enzyme. This is essential for the cleavage of the amyloid precursor protein and also for the synthesis of the beta amyloid plaques. So if you will see in the disease group, the levels of base is significantly upregulated when compared to the normal control group. So this upregulation of the base enzyme, it is saying, it is denoting that it is responsible for the formation of the beta amyloid plaques. And if you will see the levels of the beta secretase enzymes in the treatment group, the levels of the base enzyme is significantly decreased when compared to the scopolamine treated group. So in this way, further we are confirming our results in the Western blotting also. So these are the results for the base enzyme. So base is significantly elevated in the disease control group, and the levels of base is significantly decreased in case of the treatment group. So then also these are the graph for the NF kappa beta and also for the BDNF. BDNF levels were significantly elevated in the treatment group. So for the estimation of BDNF as well as the base and amyloid beta, NF kappa beta, we have done both two tests. One is the Western blotting, another one is the ELISA. In two tests, we have got the same result. Then to see the histological markers, we went for the we have done the hematoxylin and leucine staining. So this is the microscopic data after completion of the HND staining. So these are the hippocampus. So generally hippocampus, we will divide hippocampus into the 4 regions: CA1 region, CA2 region, CA3 region, and dentate gyrus region. So but mainly we will see here CA1, CA2, and dentate gyrus, CA3. So if you will see, so this is the 10x, this is the 20x. So in case of disease group, we can see that significant ballooning of the hippocampal neuronal cells as well as the formation of the apoptosis. So all these things we are observing here. So this is the 40x. So we can see at the cellular level. So this is the diseased animal histological data. This is the normal control data here. There is no ballooning, there is no apoptotic features. But here if you see complete ballooning we have observed in the hippocampal neuronal cells. So but in case of the treatment with this saraglitazar group, there is no ballooning, there is no apoptotic features, there is no formation of the inflammatory cells. So this is the histopathological data of our study. So in this way, we have executed our study. Then we went for the drafting the paper. Then we have selected some journals. So overall, in conclusion, what we can say from this particular study is, so whenever we are giving the scopolamine, it will go and bind with the muscarinic receptors, and it can able to cleave the amyloid precursor protein. Because of the formation, because of the cleavage of the amyloid precursor protein, it lead to the generation of amyloid beta plaques. This amyloid beta plaques will activate the inflammation pathway as well as the oxidative stress pathway, and this oxidative stress as well as the inflammation, and also this amyloid beta, what it will do, it will also decrease the synthesis of BDNF. Together, the decreased levels of the BDNF, increased levels of the amyloid beta, and increased oxidative stress, increased neuroinflammation. Altogether, they are causing the neurodegeneration, and it is leading to the Alzheimer's disease. So whenever I have administered my drug, that is the saraglitazar, PPAR alpha as well as the PPAR gamma agonist, it can able to inhibit the formation of the amyloid beta plaques by decreasing the expression of base enzyme. Because of the decreased base enzyme, there is no formation of the amyloid beta plaques. If there is no formation of the amyloid beta plaques, then there is no activation of oxidative stress, there is no activation of inflammatory mediators, and also there is no inhibition of the BDNF. Altogether, it is leading to there is no neurodegeneration. So in this way, my drug is working. Then we have drafted the paper, we have communicated to the journals. So then we have published in one of the prestigious journal, that is the ACS Chemical Neuroscience, American Chemical Society, ACS Chemical Neuroscience. It is having impact factor 5.1. So in this particular journal, we have published our study. So this is the neuroprotective effect of saraglitazar on scopolamine-induced Alzheimer's in rats, and also insights into the underlying mechanism. So this is the outcome of this particular research. So in this way, if you plan your research, you can publish your work in very good impact factor papers. Not only index, you can go for the very good impact factor papers also you can publish. So further, like we have extended our study in the like Huntington's disease also. So further, like by using 3-nitropropanic acid model, we have developed a model to screen the Huntington's disease also. With that particular study, also we have published one more paper. It is elsewhere paper. This is neurotoxicology. It is having impact factor 3.5. So we have screened neuroprotective effect of saroglitazar even in 3-nitropropanic acid induced neurotoxicity also. And also we have explored the underlying mechanism. So with this particular experimental design, we have published these 2 papers. So yeah, as per the introduction, now I'm focusing on the neurosciences. Also, we are doing on the organoprotective studies also. So this is my team. So with help of my scholars, I'm conducting this particular study, and I got this particular outcome. So thank you. And also just last 2 minutes, like so for example, to know like whether it is Scopus indexed or not, please go for the SIMAGO journal rankings. It will be helpful for you. Okay, sorry here, I couldn't able to show you. 1 minute. So this is the best platform, SIMAGO website. The site is visible. Yeah. So please, whenever see, like you may spend 2 to 3 years for designing your studies and also to execute your projects, and all these things you will spend more time. So please try to submit your work in the authenticated journals. So to help to find the authenticated journals, this particular website will help you. So for example, here, for example, if you see like European Journal of Pharmacology, just type like European Journal of Pharmacology. So it will take to you. So this is the European Journal of Pharmacology. So just click on the European Journal of Pharmacology. It will give all the details related to the European Journal of Pharmacology. So what is the H index of this particular journal? What is the ISBN number? What is the for books ISBN number will be there. What is the ISSN number? Scope of the journal. So from this, you can go for the home page. So this is the best way to go for the home page, because with the same European Journal of Pharmacology or maybe with some other names, n number of websites are available nowadays. They are generating cloned websites with the same name. So to avoid like to know which one is the authenticated website, which one is the cloned website. So please go to the SJR website. From SJR, you can select the home page. Then it will redirect into the home page of the European Journal of Pharmacology. So see, this is the European Journal of Pharmacology website has come. So from this particular European Journal of Pharmacology, you can submit your manuscript. So from submit your article, you can go for this one. So because I have experienced so many cases, so that's why I'm intimating you. So please use, this is the best platform to select the original homepage. So nowadays, what is happening? So many Chinese journals has come, some Korean journals, and what they are doing, like actually they are authenticated only, but some other people's, they're with same name of the journal, they are starting their own website. And one more thing also, please remember that whenever we are uploading our paper to the other country, like Chinese journals or Korean journals or European journals or American journals, so please remember one thing, they never ask money in rupees. So that is also like, if for example, if you don't know to select the, maybe like because of some mistake, you might have uploaded your paper in the cloned journal. So in the cloned journal, if it is not Indian, that is not Indian journal, maybe it is the international journal, maybe publisher also in the European Union, or maybe from the like in Asia also, other countries. So then they will never ask in rupees, like 10,000 rupees per journal, 15,000 rupees per journal, 20,000 rupees per journal, like that they never ask. Always they will ask in the dollars only. So someone, if any, like during your communication process, if they are asking money in rupees itself, it is saying that that is the cloned journal. If it is Indian journal, maybe they will ask in the rupees. But if it is international journal, they never ask in the rupees. They will ask in the dollar form only. And also, if they ask transfer money through the phone pay or Google Pay, then it is absolutely cloned website. Okay, so never international, like this UPS only, it is restricted to India. Okay, so they never use like international companies, international journals. They will never ask transfer money through the phone pay or Google Pay. Okay, so and also they will never ask in rupees. So they will ask money only in dollars, $1,000, $500, $2,000. They will ask in dollars only, because that is the international transactions. So please keep these two things in your mind. So for, and also like you can use Journal Finder for selection of the journals also. Okay, so with this thing, thank you once again. I'm saying thank you, sir. Thank you very much for providing this opportunity. If anyone is having any questions related to this research or related to their PhD or relating to communication of the papers, so anything I can help. So if anyone having any questions, you can ask me. So because of the limited time, like I have explained everything in very fast manner. So if you have any questions related to your research, you can ask me. No need to ask from same topic also.
सर एक क्वेश्चन था,
Okay.
हम क्लोन जनरल और रियल जनरल को
Yeah.
कैसे पहचान सकते हैं?
Yeah. For that only, like मैं बोल रहा हूँ, like if you go for this particular SJR website, SJR, Simago Journal Ranking website, from that particular website, we can find the homepage for the journal. So if you will click on that particular homepage, it will direct you into the original journal only. You cannot find any, it will direct only to the original journal page only.
Okay.
Is it clear, sir?
Yes, sir. Thank you, sir.
Yeah, please note it down, Simago Journal Ranking. So that is the best website to find out the original journals.
Okay.
So from you, please try to upload your paper only through the SJR linked homepage only. Never directly, don't search in the Google for the journal. So if you search in the Google, it will give 2 to 3 websites. We don't know which one is the original website, which one is the cloned website. Nowadays, cloned journal people, they are claiming that this is the original journal, like that they are claiming. Okay, so this is the thing.
Okay.
Yeah, anything?
So someone put a message on chat, sir. They asked a question.
Okay. Yeah, okay. What is per se control group? So, like per se means like it is no need to include in all the experimental designs. If you are interested, you can include the per se control group. So, per se means like only drug, no disease. Per se means only drug. If you want to see any toxicity of the drug, then we can include the per se group. So, for we will give our drug to the normal animals, and we will see the toxicity. Like this particular drug, it is showing any toxicities or not. In that way, we can include the per se group. If, for example, already extensive studies were conducted on that particular drug, if that particular drug is proven that it is very much safe, then no need to include the per se group. If we want to see the toxicity of that particular drug, alone drug, then we have to include the per se group. So means no disease, only we will give the treatment.
Sir, good morning, sir. Pawan, sir.
Yeah, good morning.
It's me, sir. Sevaji, sir.
Oh, Shivaji, yeah, how are you?
Yeah, fine, sir.
Yeah, please go on.
Sir, I have one doubt, sir.
Yes,
Sir,
yes.
entire your scenario is very nice, sir. Wonderful session. But I have small doubt
Thank
for the Alzheimer, the Parkinson in Alzheimer, sir. So
Okay.
nowadays, repurposing drugs are available, sir. So that therapy is
Yes.
suited to the in your scenario, sir.
Yeah, that's why this is whole concept is related to repurposing itself. So already saraglitazar it is available to treat
Sir.
the diabetes dyslipidemia. Already it is
Okay, sir.
available. This drug is FDA approved drug. So that's why I have explored whether it is having any role in the neurodegenerative diseases also. So that was
Okay.
repurposing was my main intention. In that way only, I have explored this particular targets. Role of this, is there any, these particular targets are involving in the neurodegenerative diseases. So then in the literature, I found that a very good connection that yes, PPR alpha as well as PPR gamma, both these receptors are involving in the neurodegenerative diseases. So whenever after in death after completion what I can say in postmortem brain samples it is very much explored that this both PPR alpha as well as PPR gamma levels were significantly reduced in the Alzheimer's disease. So it is itself it is showing that yeah, PPR alpha as well as PPR gamma, if we can able to stimulate PPR alpha as well as PPR gamma, then we can give some amount of neuroprotection. That was the idea behind this. So in that way, whenever you want to go for the repurposing, so please select some targets. Based on the target,
Okay.
you can select the existing drugs in the market.
Okay, sir. Okay.
Yeah,
Thank you, sir.
that is good strategy nowadays. Repurposing is good strategy.
Yeah, sir. Maybe I can choose so recently qualified the RSET, sir. I got the
Oh,
seat
good,
in
good.
Andhra Kesar University.
Okay, okay.
I call you, sir,
Yeah.
personally. Yeah,
Okay,
many
okay,
members
okay.
are there.
Yes, yes,
Okay,
yes.
thank
Okay,
you,
no.
sir.
Okay, okay. Yeah, please. I am not audible. Any questions? So please, just one sincere advice is don't go for the whole day kind of drug discovery. Please select some target, go target oriented research, and it will, what I can say, it will promote your publication also. Any questions?
Hello, sir. Sir,
Yes,
good
madam.
morning, sir.
Yeah, good
Sir,
morning.
when we are, for example, we have formulated a drug in combination, so we
Yeah.
will be having two drugs. So in such case,
Yes.
how will we check the pharmacological activity on the animal?
No, generally, we will for two form I'm not
Like for
it is like a
example,
fixed
I'm
one
for
minute, 1 minute.
example,
Yeah.
I have one example like emtricitabine is
Okay.
there. Along with
Okay.
emtricitabine, we will be using tenofovir, right?
Okay. So you can keep
So in such
yes, yes.
cases,
Yes. Now I understood. Now I understood your now I understood your question. So no, nothing like in case of experimental design, one with the drug one, you will keep one drug. With the drug B, you will keep another group. Then that combination drug A plus B will be there. For that, another group you will keep. So now after that, whenever after completion of the your work, you will compare your results with the now combination result, combined results you will compare with the drug A, combined results you will compare with the drug B. If it will show any improvement, then you will see the significant difference. Based on the experimental design only, in experimental design, we will keep one more group, extra group we will keep for the combined formulation.
okay.
That data we need to compare with the individual drug data. So then we know that whether it is having any beneficial action or not. So for example, if you are getting same kind of activity for all three, drug A, drug B, then combined formulation also, then we can say that there is no beneficial from the combined formulation. If we will get better result when compared to individual drugs, then we can say that yes, my drug is having the good activity. So just we need to incorporate one more additional group in case of combined formulations are involved.
Okay, sir. Thank you, sir.
Okay, thank you.
Thank you, sir. Thank you for sharing your insights on the topic, sir. We learned a lot from your presentation. Thanks for your sharing expertise. I am sure this session would be very helpful to the participants.
Yeah, thank you, madam. Thank you so much. Once again, I'm very much thankful to you as well as your principal sir and your society for inviting me for this particular faculty development program. Thank you, madam.
Thank
so
you very
much.
much, sir. Now we are respecting you, sir. We are sharing our your appreciation certificate, sir. Thank you for your
Okay, okay.
valuable time, sir. Now I'm sharing the
Thank you, madam.
certificate, sir. I personally mail you, sir.
Okay, madam. Okay. Thank you.
Yes. I'm
Yeah, thank you all. Thank you.
Sir, 1 minute, sir. I'm showing the certificate of yours, sir. Yes, sir. Thank you so much, sir.
Okay, madam. Okay. Thank you.
Thank you so much, sir. Thanks for your time, sir.
Okay, madam. Thank you.
All the participants, could you fill your Google form? I'll give you on the chat box. Please submit by today evening only.